Welcome to One-on-One Tutorials. Please visit our website at www.oneontutorials.hostzi.com. In this tutorial, we are going to discuss some more problems on electricity, and in the next tutorial, we will be discussing the solutions. So while seeing this video, whenever necessary, you stop the video and write your solution, and in the next tutorial, when we will be discussing the solutions, please compare your solution with ours to make sure that you got all the answers right. Okay, the first problem. Given below are names of few substances. You have to identify which of these are conductors of electricity by writing a -C, and which are insulators by writing -I next to it. The substances are nichrome, graphite, mercury, mica, porcelain, cotton, silver, paper. So these are the 8 substances against which you have to write whether they are good conductors or they are conductors or non-conductors, that is insulators. Insulator and non-conductor are actually same. Next, there are few fill in the blanks. Let me read the first one. Potential difference is measured in the unit of, you have to write the unit of measuring potential difference here by using an instrument called, there is a blank here, you have to mention which instrument is used for measuring the potential difference, placed in, I will not say anything here because if I say, you will immediately understand the answer, across an electrical conductor. The next question, that is also fill in the blanks. Copper is a good, there is a blank here, of electricity, but plastic is an, there is a blank. I will not give any hint because if I give the hint, you will immediately know the answer. Third, fill in the blank. Presence of free blank or blank makes a substance good blank of electricity. Next one, volt per joule can also be expressed by the unit called blank. Next one, coulomb is the unit of blank. Next one, amount of work done in moving 1 coulomb of charge against a potential difference of 1 volt is, there is a blank. So fill in the above blanks. Now we will go to the numerical problems. Till our last tutorial we did 3 problems, so this is the 4th numerical problem. The 4th one is this: calculate the work done in moving a charge of 4 coulombs from a point at 220 volts to another point at 230 volts. So let me read again. Calculate the work done in moving a charge of 4 coulombs from a point at 220 volts to another point at 230 volts. Numerical problem number 5. How much energy is transferred by a 12 volt power supply to each coulomb of charge which it moves around a circuit? Let me read again. How much energy is transferred? Remember, energy is nothing but work done. Okay, just I gave you a little bit hint here. How much energy is transferred by a 12 volt power supply to each coulomb of charge which it moves around a circuit? Let me go to numerical problem number 6. What is the potential difference between the terminals of a battery if 250 joules of work is required to transfer 20 coulombs of charge from one terminal of the battery to the other. Let me repeat again. What is the potential difference between the terminals of a battery if 250 joules of work is required to transfer 20 coulombs of charge from one terminal of the battery to the other? Numerical problem number 7. Do not look at the solution now. I'll explain the solution later. Okay. Let me hide the solution. Okay. 3 2-volt cells are connected in series in a circuit. Draw the diagram also. 3 2-volt cells. So draw the diagram where you show all the 3 cells. 3 2-volt cells are connected in series in a circuit. Question number 1. What is the potential difference? P dot D stands for potential difference. What is the potential difference at the terminals of the battery? Next question. How many joules of electrical energy does 1 coulomb gain on passing through? Now this again has two parts. Now first part is one cell and second part is all the 3 cells. Okay. So second question, that is question number B, again has two questions. You have to give solution for both. Okay. So how many joules of electrical energy does 1 coulomb gain on passing through? Question number 1, one cell, and question number 2, all the 3 cells. So for this problem you also have to draw a diagram where you have to show all the 3 cells, each having 2 volt. Okay. So you work out these problems, derive your own solution, then compare with our solutions.